So welcome dreamers. Swati Kumar. Hello sir. Good evening. Yeah, Vipin sir. Hello sir. I'm teaching in college and I was your student in ESE. क्या बात है? Superb. All the rest of the students who are present, please mark your presence by commenting something so that we'll start. Vipin, great to see you after a long time. I think so. Yeah. Good evening, Farhat. Right. Swati Kumari. Good evening, everyone. All the rest of the students, we have very beautiful questions are coming up right now. Very interesting questions are heading towards you now. Very scintillating questions. I'm audible and everything is visible, so that we'll start our session. Hey, Kiran Kumar, good evening. Rajat Mishra, good evening. Yes, Rajat. Yes, Kiran Kumar, good evening. Everything is set? Yes, fine. If everything is set, we'll start our session now. Right, fine. So this is what exactly question number first is. This is DRDO question. Let's see. Let's see now a DRDO question. Mohit Gupta in this session, how the problems and the PIQs. No PIQs. We have very new questions we selected basically from ISRO DRDO BARC. Let's see that. And very interesting information I'm going to share here. Right? TPM, sir, in a DRDO mains conventional paper, it will be theory numericals. Right? Fine. So let's see that. Question number 1 is there. Very simple. The chaplets are used. Chaplets are used in the mold for. So what is the reason for utilizing of the chaplets are right? Fine. Enhancing the rate of solidification, or providing additional metal to the casting at its strings, or carrying up gases produced during the casting process, or providing support to the core. Right, fine. So when the core prints are not sufficient, absolutely correct. So we'll say that, sir, the chaplets are basically utilized to provide the support to the core and avoid the bending of the core. Avoid what? Bending of the core. Because we know that whenever the core is utilized, when the core is utilized, core is basically utilized to manufacture hollow castings. So whenever I talk about here core, whenever the core is not sufficiently supported, then we have to utilize chaplets. So basically chaplets are manufactured from the same metallic material as that of the molten metal that we are going to pour. Absolutely correct, everyone. So I'll say that, sir, my answer would be what? Sir, it is basically providing the support to this particular core. So this will be exactly equal to my answer, providing support to this particular core. Is it okay? Yes, Rajat Mishra and everyone. Yes, super. Right, fine. Next question is coming. Now this is also ISRO question. Addition of a coal dust to the green molding sand is to improve. Why the coal dust is utilized in a green molding sand? For improving the permeability or improving the surface finish of that particular molding sand, the moldability or green strength. What is that? So Vipin sir is saying the green strength. Why the addition of coal dust is utilized in this particular case? Surface finish or double lover? Is it Bombay B surface finish? Coal dust is utilized. Coal dust. Farad Umsa, let's see that. So Delhi D, okay. Mani Viravalli, okay, Mani. So let's see that, sir, coal dust is basically not utilized to improve all these parameters, man, basically, right? Coal dust is utilized for improving, am I audible? Is it audible, everyone? Yes, sir. Vipin sir, D. Yes, sir. Basically, whenever we talk about coal dust, right? Coal dust is utilized for improving the green strength of this molding sand. Absolutely correct. Green strength of molding sand is improved by this particular coal dust. Right? Fine. Now, one more question is coming by the ISRO 2014. This question was asked. Very interesting question. Let's see that, sir, two castings of a same metal have the same surface area. Two castings, same metal and same surface area. One casting is in the form of sphere and the other is in the form of cube. What is the ratio of solidification time for the sphere to that of the cube? What is the ratio of solidification time of the sphere to the cube? Surface area is same, right? Fine. The two casting of a same metal have the same surface area. One casting is in the form of sphere and the other is in the form of cube. So what will be ratio of solidification time? Can we able to calculate what is the rate of solidification time there, or what is the ratio of solidification time? So it's very simple that if you try to answer that, whenever we talk about solidification time of a sphere, solidification time of a sphere is exactly equal to, what is that, sir? Mold constant K into volume by surface area. Volume by surface area. So can I say that the ratio of volume by surface area, whenever we talk about sphere, can I say modulus of casting, or modulus of casting is coming d by 6. Right, d by 6. We know that volume by surface area. What is the volume of sphere? 4 by 3 pi r cube. And what is the surface area? 2 pi r square. Right, fine. You can convert it to diameter. So 6 divided by, or d by 6. Right, fine. Now, whenever we talk about the cube, right, fine, cube. Now I'll say the solidification time of the cube. Right, fine. So I'll say the solidification time of the cube is K into, again can I say that it will be coming A by 6. It will be coming what? A by 6. Suppose I will say that, sir, A is exactly equal to a side of the cube. A is exactly equal to side of a cube. Side of a cube. Right, fine. Now it was given that surface area are both the same. So if the surface area is same, can I say that surface area of a cube is exactly equal to surface area of the sphere? Surface area of the cube is exact surface area of square. If the side is A, so can I say it will be exactly equal to, what is the surface area? 6a square. Whenever I talk about cube has the 6 faces. So one face has surface area A square. So 6 faces is 6a square. And what is the surface area? 4 pi r square. 4 pi r square. Is it okay, everybody? 4 pi r square. Yes. Can I able to set a relation between r and a? So can I say a here will get exactly equal to 4 by 6 into pi into r square. So we can get a value here, right? Fine. A will get in terms of r. A will get in terms of r. Is there anyone calculated? Right, fine. And whenever we get that value, I have to take a ratio here. Can I say that you take a ratio of this? What is that? The sphere to the cube. Right, fine. I'll take a ratio here, sphere to the cube. When I take a ratio, can I say that I don't require to use this? I'll use here like this. What I'll use? I cannot use like that. I have to cancel. So solidification time of the sphere to the solidification time of a cube has to be exactly equal to that volume divided by surface area. Volume divided by surface area. Volume divided by surface area. Here also divided by tau into, divided by what? Tau into volume divided by surface area. So what is the volume? So tau will get cancelled, or it can be considered as k, not tau. This is k, this is k. They both will get cancelled. Now what is volume? 4 by 3 pi r cube, right, fine. And surface area is exactly equal to 4 pi r square, right, 4 pi r square divided by 6a cube divided by a cube divided by a 6a square, right, fine. And 4 has to be power 2. Now a value has to be put in terms of r. A value has to be put in terms of r. When we put it in terms of r, you tell me that what is 1.909? Kiran Kumar, Mohit Gupta. Anyone calculated answer? Anyone? I don't have answer. You tell me that. What is answer is coming? Whether it is coming 6 divided by pi, or whether it is coming 3 pi by 8, 3 by 4, or 5 divided by 4 pi. What is it? 6 divided by pi. Mohit Gupta, like, absolutely correct. Bombay B is exactly equal to my answer. Right. Bombay B is exactly equal to answer. Now simplification you can do. Right. Surface area has to be compared there. Right. Very good question. Can be asked in examination of GATE. No doubt into it. No doubt into it. Right. Fine. Next question. Short but speed session is there. Next question. Again, 2016 question is asked, if you are preparing for Misrun is a casting defect which occurs due to. Why the Misrun defect is coming in the casting process? That's what question is. Very high pouring temperature of metal, because of that it comes, or aspiration of gases by liquid molten metal, or insufficient fluidity of molten metal, or improper alignment of a mold flask. Why it is coming? So we know that what is meant by Misrun defect. Misrun, which means that improper filling of casting cavity. Non-filling of casting cavity. When the casting cavity is not completely get filled by liquid molten metal, then the defect comes called as a what? Defect comes called as what? I would say that a misrun defect. Now, when it is happening, very high pouring temperature, no. After no, insufficient fluidity of molten metal. Absolutely correct. Because when the molten metal doesn't have the fluidity, and the fluidity is utilized for gases and the liquid is molten metal liquid. So when it has low fluidity or insufficient fluidity, then the entire casting cavity will not get filled properly, and therefore misrun defect will be coming in the picture. Is it okay, everybody? Misrun defect will come in the picture, right? Fine. So I'll say that my answer will be exactly equal to C. So this will be exactly equal to my answer. Let's see how fundamentally correct questions are asked in ISRO. Right, fine. Next question, ESE 2015 question was asked. What is that? A big casting have a hole to be produced by using a core of 10 centimeter diameter and 200 centimeter long. The diameter of the core is 10 centimeter, long it is 200 centimeter. The density of the metal is row density of metal is 0.077 Newton per centimeter cube, and the density that is row core is 0.0165 Newton per centimeter cube. So what is the upward force acting on the core is? What will be the upward buoyancy force acting on the core is? What will be the upward buoyancy force acting on the core is? Can somebody calculate and tell me that how much force is acting on the core basically? Mohit Gupta, 950.33. Yes, absolutely correct. 950, I think so. So how exactly it is calculated? You tell me the formula. So I'll say that, sir, the buoyancy force, right? Buoyancy force acting is exactly equal to, what is the formula for buoyancy force? Density into, volume into gravitational acceleration into what? Into exactly equal to the density of metal minus density of a core, right? Fine. Sir, we know that, sir, directly G value is not required here because directly these densities are given in the Newton per centimeter square, right? Fine. So 9.81 I don't require there. So what is the volume? Volume is exactly equal to pi by 4 into 10 square multiply by this, and then multiply by density of metal is 0.077 minus density of core is 0.0165. Are you accepting, everybody? Yes. So core may be of any shape or a cylindrical shape always. Most of the time core is a cylindrical shape, most of the time. Because generally whenever we are interested to create a hole, that has to be circular. But there is no necessity that every time core has to be circular by default. Because core can be of any shape, technically speaking. Right, fine, technically speaking. And my answer is coming exactly equal to, how much it is? 950.32 Newton. Is it okay, everyone? 950. Why? No. It's not basically based on that. Core, why is it cylindrical? That means what? What is the use of core? Core is basically utilized for creating what? Creating a hollow casting. Now, if in the hollow casting I require to create a hollow portion generally, then I have to use a hollow core. Generally, it is not necessary that it has to be every time is a hollow only or circular only, because generally what happens, we know that if I talk about a square or something about the different cross section, what happens? Whenever I am pouring the molten metal, when the contact area of molten metal with the core is greater, it will dissipate the heat to the core. And therefore, as it is rapidly dissipating the heat to the core, what will happen? The time required for solidification of material will reduce drastically and quickly material will solidify. And therefore, there might be chances that before filling the casting cavity completely, there might be chances that material might start resolidifying. And there might be reason that generally in the casting process, whenever we are interested to produce a core or hollow casting, we generally go for cylindrical one. In the case, sir, in this case, how many? Now it is depending upon basically a chapter. Let's say that now what is the core print? Core print is also coming in the picture. What is the core print? Core print, which is nothing but called as a area which is supporting this particular core. every 1 Newton of material or every 1 Newton of unsupported load will generate a core print or chaplets of whatever I say that, whatever this particular, I would say that, what are you asking? What are you asking? Sir, in this case, how many chaplets are required? Let's see. How many chaplets are required? That is solely depends upon unsupported load. And what is meant by unsupported load? It is depending upon how many core prints are provided. And whatever the 1 Newton force is unsupported, 29 millimeter square cross section area chaplet is utilized. What is the relation? 29 millimeter square cross sectional area of the chaplet is utilized for every 1 Newton unsupported load. Every 1 Newton unsupported load. 29 millimeter square. Right, fine. Now it is depending upon how much is the core print, what is the area of the core print, and that is nothing but exactly equal to how much force is acting minus 350. That is area of the core print. That is nothing but buoyancy force minus 350 multiplied by A, and A stands for area of the core prints. Now, if this value is coming positive, when it is coming positive, when the buoyancy force is greater than this, then therefore this value is coming positive. That will be act as unsupported load, and then there will be chaplet comes in the picture. Then there will be chaplets are coming in the picture. Is it okay? And A stands for what? Area of the core print. A stands for area of a core print. Area of core print. If this subtraction is coming 0, no unsupported load, and if it is coming negative, which means that, sir, there is no unsupported load, we don't require. Yeah, this is standard value. 350 multiplied by area. A stands for the area of the core print, and BF stands for that buoyancy force acting. And every 1 Newton unsupported load is coming. That for that 29 millimeter square, a chaplet has to be provided. Unit of area is what? Millimeter square. Millimeter has to be considered. Yes, 29 millimeter square. Super. Absolutely, Mohit. Money. Yes. Yeah, very correct. Right, fine. Next question. Now let's say that this question was asked gate examination. No, nobody is talking to you. What is the question? Question is asked gate examination. In a casting process, the vertical channel through which molten metal flows downward from a pouring basin to runner for reaching the mold cavity is called. What it is called? You tell me that. Now this is the balle sir. It is what was given that when a vertical channel through which molten metal flows downward from pouring basin to the runner. So if we talk about the casting process, can I say that, sir, pouring basin is there and it is flowing the material to the horizontal runner. What is that vertical member called? That vertical member is nothing but called as what? It is called as basically a what? Sprue. It is called as what? Sprue. And this is gate examination for you. And that is 2019. No way back, right? Blister is not coming anyway here. Fine. Next question. What is the next question? Sir, with a solidification factor of 0.97 into 10 to the power of 6 second per meter square. So Mohit, if you have a doubt, you come down to my Telegram channel and write me message. I'll contact you and tell you, because here we have to solve. Rest of the students are also watching. They'll get disturbed here. So whatever the problem is there related to this, we'll solve it. So now the solidification time in the seconds for spherical casting of 200 mm diameter is. So how much will be a solidification time for this particular spherical casting of 200 mm diameter is? Sir, it's very simple. What is it? Solidification time is exactly equal to K into volume divided by surface area whole square. Right, fine. So I'll say solidification time tau is exactly K. So how much value of K is there? So I know that the K is given 0.97 into 10 to the power of 6 second per meter square multiplied by volume by surface area. For spherical casting it will come what? D by 6 whole square Now what is the diameter? Diameter is given 200 millimeter, but it has to be put in meter because it is given second per meter square solidification constant. So diameter has to be put 0.2 meter, 0.2 meter and not in millimeter. And now if I put it there, solidification tau is coming. How much is solidification time? Solidification time is coming D, Vivin Kumar. Yes, fine. So how much is Bombay B? 1078 seconds. 1078 seconds. Absolutely correct. 1078 seconds. Is it okay? 1078 seconds. Superb. Right, Mohit Gupta? Superb. Superb. One more question is there. Let's see what is it. What is it? In a sand casting operation, the total liquid head is maintained constant such that it is equal to the mold height. So whatever the mold height is there, that is exactly equal to what? The liquid head is maintained constant such that it is equal to the mold height. Right, fine. The time taken to fill the mold with a top gate is TA. If the same mold is filled with a bottom gate, then the time taken is TB. Ignore the time required to fill the runner and the frictional effects. Assume atmospheric pressure at the top of the molten metal surface. The relationship between TA and the TB. So how much will be a relation, or what will be a relation between that? Mohit Gupta, 2TA. What is the relation between that? TB is equal to what? Bombay B. Kya baat hai? Vipin sir, Bombay B. Yes, absolutely correct. So because we know that, sir, in a sand casting it was given that total liquid head is maintained constant such that it is equal to the mold height. Total liquid head is maintained exactly equal to the total liquid head is maintained constant such that it is equal to the mold height. So therefore can I say that some TA time is coming whenever we talk about top gating system, top gate system, and TA will be exactly equal to K into volume divided by surface area whole square. Oh sorry, I am interested to talk about a solidification time, not pouring time. So I'll say that pouring time T is exactly equal to the volume of casting divided by flow rate, right? Fine. That is nothing but choke area multiply by what? Molten metal velocity in the gating system, 2 into G into HT, 2 into G into HT. Because top gating ke liye, can I say velocity remain constant, that is A max. Absolutely correct. That is what exactly equal to velocity of molten metal in gating system. But whenever we talk about a bottom gating system, so in the bottom gating system, what is happening? Can I say liquid molten metal head is becoming exactly equal to the height of the mold. So that means, can I say at the end, can I say that the velocity of molten metal, because in bottom gating system, can I say that the velocity or potential head of liquid molten metal keep on reducing. So initially material velocity will be maximum, but the velocity will come, and at the end, as the potential head and that particular height of the mold both are same, so can I say that at the end, that is minimum velocity will become exactly equal to 0, and in the bottom gating system, can I say average velocity has to be considered, right? So therefore I'll say that, sir, the average velocity is exactly equal to Vmax divided by V minimum. Vmax divided by average velocity is Vmax plus V minimum divided by 2. Divided by what? 2. So V average will come, V average velocity will come, Vmax divided by 2. Vmax divided by 2. And this is the way by which TB has to be calculated. And if I say that TB is exactly equal to volume of casting remains same. Volume of casting what? Remains same. Absolutely correct. You are all talking about volume of casting remains same. Choke area will also remain same. Now we have to put what? Average velocity. Can I say average velocity will be Vmax by 2? Okay, fine. Vmax divided by 2. So divided by 2 will come to the here numerator. So TB is exactly equal to, can I say that this dimension, this value is nothing but exactly equal to what? TA, right? So I'll say that 2 into TA. Is it okay, everybody? Yes. Part gating system combines both time of the top and the bottom gating. Absolutely. Right, fine. So what will be answer? So Bombay B will be my answer. Is it okay? Yes, Bombay B is my answer. Perfect. Okay, fine. Now let's say that the incorrect statement, again DRDO question 2009. Let's see that what is. Generally in DRDO questions, theoretical questions are coming In ISRO also I have checked that theoretical questions will come in objective paper, right? Fine. So the incorrect guidelines for the good gating system is, so whenever we talk about designing a good gating system, what is the incorrect guidelines about below? Listen carefully. What is incorrect guideline? Rajat, Swati, Vipin, everybody? Right, fine. So what is it? Sir, it was given that the riser volume should be sufficient for compensating the shrinkage in the casting. Absolutely correct, sir. Whatever shrinkage is coming in the casting, that can be considered as a liquid shrinkage. So riser volume has to be sufficient. So it's not an incorrect guidance, it is a correct guidance. Right, fine. Less pouring time contributes to the turbulent flow in the mold. And it is also correct, because when we are trying to increase the velocity of molten metal beyond certain limit, so that filling time in the casting cavity will reduce, so there might be chances of turbulence. Turbulence will lead to a lot of problem. Right, fine. Long pouring time requires higher pouring temperature. Long pouring time requires a higher pouring temperature. Absolutely correct. If the long pouring time is required, so that means the time required for filling of casting cavity is long. So therefore pouring temperature will be also very high, because if the pouring temperature is not high, it will dissipate quickly, hit to the atmosphere, and it will start re-solidifying before the filling of casting cavity. Do you understand that? Yes. The molten metal material in the riser should solidify in the beginning. The molten metal material in the riser should solidify in the beginning. You tell me that. Is it allowed to solidify the molten material before the solidification of casting cavity? No. So molten material in the riser should solidify after the solidification of casting cavity. After solidification of casting cavity. But sir, shrinkage in the casting components will be providing shrinkage. Oh, let's see, Mohit, you are putting very right point, but let's understand that. Is it mentioned here whether it is a liquid shrinkage or solid shrinkage? Because liquid shrinkage has to be compensated by riser. Riser is there who is supplying extra volume of molten metal. When we talk about solid shrinkage, then I'll say that 100% it will be compensated by shrinkage allowance provided on the pattern. So therefore, can I say that, sir, it cannot be like that. Right? So what is incorrect guideline? So what is incorrect guideline? Delete is incorrect guideline. The molten material in the riser should solidify in the beginning. Absolutely wrong. Molten material in the riser should solidify after the solidification of metal in the casting. Is it okay? Yes. Right? Fine. Therefore, my delete is correct answer. Mohit, I think so you are understanding, right? Because if it is clearly mentioned solid shrinkage, then it is free, because shrinkage can be liquid also, shrinkage can be solid also. But even if we compare all this statement, can I say most incorrect statement is D? Because anyway, however it is, in a casting process, it is mandatory that material in the riser should remain for liquid state for longer period of time as compared to casting, as compared to solidification time in the casting. Then only it will supply liquid shrinkage. So most appropriate answer is D, even in that case. Is it correct? Thumbs up, superb. Right, fine. Next question. Let's see that. Simple question is there. A mold has a down sprue whose length is 20 centimeter and the cross-sectional area at the base of the down sprue is 1 centimeter square. The down sprue fits the horizontal runner leading to the mold cavity of 1000 centimeter cube. The time required to fill the cavities. And it is the most simple question on the earth, I would say. It is the most simple question on the earth. You should be able to calculate answer and tell me immediately. Sir, filling time calculation, volume divided by flow rate. Flow rate is nothing but the choke area, minimum cross section area, generally at the bottom of the sprue, multiplied by velocity of molten metal in the gating system. That is the root of 2 into G into HT. Yes, Kiran Kumar 5.048. Mohit, I want answer from. Yeah, kya baat. Superb. Dynamic, right? Faraz, Rajat, Swati, keep on commenting. Right, fine. So I know that, sir, solidification time calculation is exactly equal to volume of casting divided by flow rate, divided by what? Flow rate. So I'll say that it will be the choke area multiplied by velocity of molten metal in the gating system, 2 into G into HT. 2 into what? G into HT. Now it was given that what will be a volume of casting. So it is a what? Volume of casting is directly given, sir. 1000 centimeter cube, nothing to worry. Right, fine. The choke area of the down screw at 1 centimeter square. So I'll say that, sir. The choke area is 1 centimeter square. Right, fine. And height of the down screw is 20 centimeter. Every crystal clear value you put it here, and G you have to use 9.81 meter per second square. You have to multiply by 100 because meter has to be converted to centimeter. So centimeter, meter per second, instead of that, centimeter per second square. So value of time is coming exactly to 5.05 seconds. Is it okay, everyone? Yes, correct. Yes, change unit of G only. Absolutely correct. Meter per second square has to be converted. Is it correct unit? Centimeter per second square? Multiply by 100, everyone? Yes, fine. ISRO 2012. The draft on pattern for casting is provided for. Why do we provide draft on the pattern? Why do we provide draft on the pattern? Is it provided for shrinkage allowance? Is it provided for identification? Is it taper is provided taper to facilitate removal from the mold, or machining allowance? What it is basically? Nora Patay is joined, and C. Kiran Kumar C. Sir, it's very simple. Draft allowance is provided for only one reason. That is nothing but withdrawing of the pattern from the mold boxes. For making the withdrawing of the pattern easy from the mold boxes, draft allowance is provided. And therefore, I'll say that it is not utilized for shrinkage allowance or identification or machining allowance. It is only provided for what? It is only provided for what? Taper to facilitate removal from the mold boxes. So I'll say that the C will be exactly a correct answer. C will be exactly equal to a correct answer. Draft on the pattern has to be provided only for withdrawing, easy next withdrawing. And sometimes you know that there are certain material, wax metal is there, plastic metal is there, polystyrene metals are there. In such a material, the withdrawing takes place either in liquid or gaseous state, and in that case 0 degree draft allowance is provided. 0 degree draft allowance is provided. Is it okay, everybody? Okay, super. Right, this is what exactly draft allowance. One more question. What is that? For the case of molding, for the what? Case of molding, it is decided to replace a spherical riser of a diameter 100 mm by the cylindrical riser. So first of all, spherical riser was there, and now it is replaced by a cylindrical riser. Determine the size of the cylindrical riser that will have the identified, or that will have the identical solidification time. Identical solidification time. Assume blind risering and ratio of height to radius of the cylinder is 2. Height to radius is 2. Can you calculate that? Height to radius ratio is what? 2. Height to radius is ratio is what? 2, right? And blind riser. Blind riser is what? Not exposed to atmosphere. It is called as blind. We must have understood that there is open riser and blind riser. Top cylindrical riser or top riser and side riser. Right, fine. Can we able to calculate answer? Anyone? Number of students are there. So let's see that, sir. Let's see that it was given that the solidification time should be identical. So solidification time of the sphere, right, exactly equal to solidification time of A. Solidification time of what? A spherical, or that is what exactly equal to cylindrical riser. Is it okay, everybody? Yes. So what is the solidification time for the sphere? That is K into volume by surface area. I'll say that D by 6, right, X square is exactly equal to, I'll say that K into cylindrical riser, where can I say that riser and ratio of height to radius of cylinder is 2. Ratio of what? Height to radius. So I'll say the ratio of height to radius is exactly equal to 2, which means that H is equal to 2R. That means, can I say height is exactly equal to diameter? Can I say H is exactly equal to D? Assume blind risering and ratio of height to radius of cylinder is 2. That means H by R is 2. Right, fine. That means height is 2 times radius, which means that H is equal to D. Radius means what? Diameter. Diameter of that cylindrical riser. Right, fine. Now, it can be also coming D by 6. What is the answer is coming? What is the answer is coming? H by d case here, absolutely correct. B, so it is coming again d by 6 whole square, because we know that cylindrical riser, if I put volume is equal to pi by 4 into d square into h divided by surface area, top surface area and circumferential surface area, again it will reduce to d by 6, again it will reduce what, d by 6. Now k will get cancelled. Can I say d is equal to d? Can I say that Bombay B is correct? So if it is the diameter is 100 mm, then the cylindrical riser will be exactly equal to 100 mm. Is it okay? Yes. Very interesting question. Very interesting question. Both are coming same. Both are coming what? Same. There is a one scintillating question was asked that is neglected most of the times, and that is what chance now in competitive examination. Right? What is it? Right? The permeability of molding sand was determined using a standard AFS sample by passing 2000 cubic centimeter of air at a gauge pressure of 10 gram per centimeter square. If the time taken for air to escape was 1 minute, the permeability number is. There is a time required to escape the air is 1 minute. So how much will be a permeability number here? Can we able to calculate permeability number? One numerical is there on permeability number that you cannot escape. Anyone calculate answer? क्या बात है मोहित गुप्ता, सुपर मैन. Mohit Gupta, please drop me a message on my Telegram channel. I want to have interaction. We'll enroll you into some session of BYJU'S Exam Prep. You and Kiran Kumar, I think so. Kiran, you also, please drop me a separate message on my Telegram. I want your numbers. Swati Kumar D50. Sir, we know that, sir, the permeability number Pn is exactly equal to V into H divided by PAT. That's it. V into H divided by what? PAT. As simple as that. Correct. P into A into T. So what is V? V stands for A. V stands for what? Volumetric or volume of the air passed. That is exactly equal to 2000 cubic centimeter. What is the height? Height of the standard sand specimen. And we know that standard sand specimen has the same height and same diameter. That is exactly equal to 5.08 centimeter. 5.08 centimeter. Right? Yes, absolutely correct. 5.08 centimeter. Right, fine. Divided by P, the pressure at which the air is being passed, and that is 10 gram per centimeter square. A, cross section area of the sand specimen, cylindrical sand specimen, pi by 4 into d square, that is again standard sand specimen, 5.08 centimeter square, multiply by time t, and time t has to be mentioned in what? Time t has to be mentioned in a minute, and we know that standard sand specimen d is equal to h is equal to 5.08 centimeter, 5.08 centimeter. 5.08 centimeter, right? Fine, and that is exactly 1 minute. So therefore permeability number Pn is coming. How much it is? 50.1. 50.1. What is the unit of this permeability number? Is there any unit? Is there any unit of permeability number, my dear friends? Sir, it is unit state quantity. It is just a number. Permeability number is increasing. The porosity of that particular is increasing. Yes, no unit. No unit. Yes, fine. The DRDO 2008 question was asked. Very thin. What is that? When the molten metal is poured into mold, it passed through the following items in sequence. Now you must have understood that whichever questions I consider as far as DRDO is concerned, can I say they are all simple questions? Can I say that they are all so simple questions? Right? You can go and check the previous year, all the questions exam conducted by DRDO and ISRO. You'll amaze that. Right, fine. Sir, we know that, sir, material comes to the sprue, then it will come to the runner, then it will come to the gate, right? And then the top riser. Are you accepting? This is not exactly, right? As simple as that. A is exactly equal to answer. A is exact, because we know that I'll start pouring molten metal. Now it will come to this particular pouring basin first. Then for pouring basin, it will come to this particular vertical sprue. Then it will come to the horizontal runner. Then the casting cavity will get filled, and then top riser or side cylindrical riser. Once the casting cavity is filled, then the metal will start rising into that top riser or side riser. It may be anything. This is side riser is coming in this particular figure. This is what? Side riser is coming in this particular figure. Doesn't matter. Doesn't matter. It doesn't matter. Right? Accepted, everybody? Yes. Okay, one more question. Right, fine. Calculate the shape factor for the casting in the form of an annular cylinder of outside diameter 30 centimeter and inside diameter of 20 centimeter and height is 30 centimeter. Correction factor is K1. Only always correction factor consider one only will be. Can you able to calculate shape factor? Shape factor of hollow casting. Shape factor of hollow casting. I hope so you are understanding that, right? Shape factor of what? Hollow casting. Anyone calculate answer shape factor for hollow casting? Yes sir, shape factor is exactly length plus width divided by thickness. Is it true? Yes. Sir, shape factor is exactly equal to length plus width divided by thickness. Length plus width divided by thickness. Kiran Kumar, Mohit Gupta, Vipin sir, all the rest of the students. Swati Kumari, Rajat Mishra, right? 21.77. Paratus was 21.77. Yes, absolutely spot on. Absolutely spot on. So it's very simple that what is given, sir, length of this is given, length or height, whatever it may be. So I'll say that, sir, this has a length exactly equal to 30 centimeter. Right, fine. Inside diameter is given exactly equal to, inside diameter is given what? 20, and outside diameter is given exactly equal to 30. Right, fine. So what is the average diameter? Can I say average diameter is exactly equal to 30 plus 20 divided by 2, that is exactly equal to 825. 25 centimeters average diameter. What is the length? So can I say here length is exactly equal to height, that is exactly equal to 30 centimeters, no problem. Now what is the width? Width is exactly equal to pi d. Pi d. Circumference is nothing but, because when we cut that particular, I would say that hollow casting, like a pipe, I'm cutting that, it will be like a rectangle. So width is exactly equal to pi d, and d is for v exactly equal to average diameter. So pi into 25. Pi into what? 25. I hope you are understanding. And what is exactly equal to thickness? Thickness is exactly equal to original diameter do minus inside diameter, right? Outside diameter minus inside diameter divided by 2, which is exactly equal to 30 minus 20 divided by 2, that is exactly equal to 5. Is it coming 5? Is it coming 5, correct? So length plus width divided by thickness, answer is coming what? 21.77. Rest of the students, 21.77. Absolutely correct, man. 21.77. 21.77. Is it okay? Fine. Let's see that a cylindrical blind riser with a diameter small d and height is h is placed on the top of the riser, top of the mold cavity of a closed type and sand mold as shown in the figure. That is a closed, that is called as a blind riser is provided, and that riser is placed above this particular mold cavity. Right, fine. If the riser is of the constant volume, then the rate of solidification in the riser is the least when the ratio of h by d is. So what will be the ratio of h by d in such a way that the rate of solidification will be a least? And this is a top riser. This is what? Top riser. Top riser. We know that there are two types of cylindrical riser, top cylindrical riser and side cylindrical riser. And we know that when we talk about top cylindrical riser, can I say diameter should be exactly 2 times height, and for side cylindrical riser, can I say diameter should be exactly equal to h, and therefore I know that, sir, h by d, that is exactly equal to 1 by 2. The 2 will come to the left hand side, right? H is equal to d by 2, right? Answer will be exactly equal to 1 by 2. So answer will be what? Answer will be what? A is correct answer. What is that? The riser is the least when the h by d. H by d. So 1 by 2. 1 by 2. What is the answer? A is correct one. Absolutely correct. If I change this answer, or this instead of a top riser, if I made it side riser, then what will be your answer? Instead of the top riser, if I made it to side riser, instead of top, I say, okay, fine. It is a side cylindrical riser. What will be the answer? Mohit Gupta, permeability number has no unit because it's empirical relation. And we know that empirical relation is developed from what? Experimentation and the knowledge, and then number of factor comes in the picture where that whatever unit, if I put that, it is not considered as a unit. Answer is coming 1:1. Mohit, are you understanding that? Because that is not a derived equation. Permeability number equation, whatever VH divided by PAT, that is nothing but called as a equation, a empirical relation. That is not a derived equation. That's why that has no unit. Right, fine. Are you accepting, everybody? Yes. That's what I'm telling, that units are coming, but this has to be considered as a number only. Because if you consider that, okay, I'm putting the value of air, that is what volume of air, cubic centimeter, that is centimeters cube, then the height is there, then the pressure is there, right, fine. Neglect it. It is a unitless quantity. It's considered, right, fine. So I hope so. These many questions are there with me today because I'm not sorry with taking a lot of this. I think so today's questions are a bit of so different from the rest of the session that we have conducted. Kiran Kumar, I think so it's correct. Yes, lot of different questions are being developed and coming. Yes, even if you're able to solve previous engineering services and get questions, super. Right, fine. So thank you everybody for joining this particular session. Right, fine. We'll have one more session, not tomorrow, but day after tomorrow. And in that session, we'll try to cover metrology because from so many days, metrology is not covered. 1 mark question is definitely there on the metrology also. So on the metrology, we'll try to have one session. On the metrology, we'll try to have one session and we'll have a lot of discussion on metrology. Next session, sir. Next session is there. Tomorrow there is one more session for I'm discussing PGDM. There is one PGDM course in the NITI Bombay. So how to enroll there? That is what exactly discussions we'll have. Then day after tomorrow on the 2nd, we'll be having one more sessions related to this metrology topic. So our recorded sessions on NTM, super Mohiguta. If you want to see my real videos, they are available in the BYJU'S Exam Prep. You can download the app and you'll enjoy metal cutting and machining. You'll enjoy a number of things. I'll say that sheet metal operation, metal forming, NTM. You'll love it. I think so. Right, fine. So thank you folks everyone for joining me. If you have any doubt, Mohit and Kiran, you drop me a message on the Telegram channel. I would like to interact with all the students because these are all the assets for BYJU'S Exam Prep. I'm damn sure that we're going to score a lot of marks in coming examination. Bipin sir, thank you everyone. So take care everybody. Good night. See you in the next session folks. Thank you.